So we're going to talk just a little bit about imaginary or complex numbers. It's a new type of number. It's a number that's actually not on the number line. It's not a real number. So they're not on the number line. But they are numbers that come up in reality. So, and they're called imaginary because when mathematicians first conceived of these, they had a hard time with them. It's like, oh, I can only see this in my imagination, which is basically true. Some concepts you can represent physically, like the concept 2. I can show 2 kitties. That represents the concept 2. I can draw a number line and say, oh, look, this is 2 from 0. That kind of represents the concept 2. I can even represent the concept square root of 2. If I draw a right triangle and I make each leg 1, the hypotenuse will be this length square root of 2, so I can say this length represents square root of 2. But other concepts you can't really represent physically. Like, you can still think of them and they still have reality, but how do you physically represent honor or dignity? So these imaginary numbers, they're concepts that we can work with. We just can't draw a physical representation of them very well. So we want to look at what is the idea of imaginary number? Well, it comes from thinking about the square root of -1. I cannot show the square root of -1 on a number line, and I can't think of a real number for the square root of -1. You know, what real number can you square and get -1? Well, you can't get that negative back. So there's no real number answer to this. Because I can't think of any real number that you can square and get back to -1, because the square is going to keep turning that positive. So it's just like square root of 6. Square root of 6 is that number. When you square, it gives you 6. So I'm going to say there's a number out there that I can square and get -1, and I'm going to call it I. So we're going to call I the square root of -1. I know it's not on the number line, but I can still think of this thing that I can square and say the square of that is -1. So the two things you need to remember is we're now going to call square root of -1 I, and know that this is not a real number, so it's not on our number line. And since the square root of -1 is I, that's the thing you square. When you square I, you do get back to -1. Okay, so these are the two big ideas. And we're going to work just a little bit with these ideas. So, square root of -81. Well, yeah, that's not a real number, but now I want you to tell me more than that. The way you can think about this, there's a shortcut, but you can think of this as the square root of -1 times the square root of 81. If you introduce multiplication to your radical, you can split the radical into 2 separate radicals. So I could say this is the square root of -1 times 81. Well, the square root of -1, we now have a name for it. It's I. And the square root of 81 is 9. And that just is annoying to see it that way. We're going to write that as 9I. Okay, now, do you see the shortcut? I don't really need to go through all these steps. Square root of -25. Well, the square root of the negative is I. The square root of the 25 is 5, so I'm just going to call that 5I because that's what it is. Okay? And here, square root of -16, that's just 4I. So the square root of the -1 is coming out as the I. So we no longer, I don't want you to say that's not a real number anymore. I want you to tell me square root of -16, that's 4I. Now what about things like the square root of -40? Well, 40 is not a perfect square, so we're going to still deal with it this way. The perfect square that divides into 40 is 4. And what we want to do is keep the negative with the perfect square. We actually want to pull the negative out of the square root. So we would say, oh, that's the square root of negative 4 times the square root of 10. What's the square root of negative 4? Oh, because of the negative, it's 2i. Then root 10. Okay. Now we can also work with I, distributing it, kind of like we distribute an x, except it's not a variable. I has one value, it's the square root of negative 1. But when we work with it, it's kind of like working with x. So if I was supposed to multiply this out, I would see it's a monomial times many terms, so multiplication to several terms, that's the distributive property. So this would be 2 times 3, which is 6, and then I times I, which is I squared. So that's just like 2x times 3x is 6x squared. And then 2i times 4 is plus 8i, just like 2x times 4 would be plus 8x. Here's where it's slightly different. We're not going to leave the answer this way. I squared is the same as negative 1, and that's a lot simpler to think of. So don't leave an I squared in your answer. So I squared is negative 1, so this is really 6 times negative 1 plus 8i. So this is negative 6 plus 8i. That would be the answer. And this is called a complex number because it's got a real part. So negative 6 is a real number, and it has an imaginary part. 8i is an imaginary number. So overall, we call that a complex number. I'm not really going to test you on that. Let's get into notes 5. This problem here, when you look at it, just don't freak out with the i's. I'm pretty much going to treat these just like x's, but I'm not leaving any I squareds, okay? So, you know what this is? It's a big order of operations problem, and FOIL, and patterns. I see 2 terms. It's this answer minus this whole answer. So I know I have to simplify within each term first. This term here, I've got multiplication exponents. I better do exponents before multiplication. So it's going to be 2 times the square of that binomial. Oh, that's the square of a binomial. How can I do that? Oh, FOIL or pattern? I'm going for pattern. Square the first term. Square the 3 and the I, that's 9i squared. Multiply the 2 terms together, that's 3i, double it, and it's minus 6i because that's a minus. Square the 1, be careful, 1 squared is 1, and the sign is plus. Then minus this whole answer, I'm going to set myself up for success and put my parentheses in because I know I have to subtract the entire answer. This is not a pattern, I just have to FOIL. 4i times I is 4i squared. Outer is plus 12i, inner is minus 1i, and last is minus 3. Then I'm going to distribute the 2 and the negative. I know I squared is negative 1, but I'm going to hold off on that because I can see some like terms coming. So this is 18i squared minus 12i plus 2 minus 4i squared. Okay, now I could have added here first, but I'm going to went ahead and distribute the negative. Minus 12i plus I plus 3. I'm going to collect my like terms. 18i squared minus 4i squared is 14i squared. minus 12i is minus 24i, but add in one more, that's minus 23i. And then 2 plus 3 is 5. Now, if this was problems dealing with x's instead of i's, we'd stop right there. But we realized I squared, wait a minute, I can make that simpler, okay? I squared is -1. So why would I leave it as I squared? So this is just 14 times -1 minus 23i plus 5. And so that's just -14. So -14 plus 5, that's minus 9 minus 23i. And there's your answer. Okay. Now, again, because this is done in class, I had to skip this. But this problem is really good if you can get in, get the insight. If you had to square this trinomial, notice that's 3 terms, you could FOIL it. And you distribute a lot. You take the 2x times the 2x, the 2x times the 3, the 2x times the -i. Then the 3 times the 2x, and the 3 times the 3, and the 3 times the I, and then the -i. You actually get 9 little products. But if you kind of scoop the 2x plus 3 as a unit, because that's the real part, and let's just call it kitty. I'm going to replace the 2x plus 3 with the kitty. I can see this as kitty minus I squared. I can see it as a binomial squared, which means square the kitty, multiply the I and the kitty together, double it, so 2i kitty, plus square the I. And then I realized, oh, you know what? That kitty was there to just help me see what's going on. Kitty really stands for 2x plus 3. So I really have 2x plus 3 squared minus 2i times 2x plus 3 plus a -1, because I squared is -1. I got to use the square root binomial pattern again. Square the 2x, get 4x squared. Scoop these two together. 6x, double it, it's 12x plus 9. Distribute the -2i, you get this. And then add your like terms, and it's a mess. But forcing things to sort of fit shortcuts or fit things that you want to do, it's a really good skill. So we substituted the kitty for the 2x plus 3 to see how we could use patterns to speed this up. And I'm going to do one last thing, just a quick review, top of note 6. Just to remind you, I, by definition, is the square root of -1. So I equals the square root of -1. I got it right here. And that means I is that number when you squared gives you back -1. So remember, I is defined to be the square root of -1, and when you square I, you get -1. So as you can see, the next video will be fractional exponents.